So we're continuing our area of a polar curve. It's just another example. So we're going to be asked to graph and then find the area that it encloses. So we're going to plug this calculator in two ways, one with the graphing calculator and one with Desmos. So let's start with the graphing calculator. First thing you want to do is click on mode and change it to polar. So you go to mode, you scroll down, make sure it's not on function anymore, and you move over to polar, hit enter. Now when you go to y equals, it'll say r equals. So we go 2 plus sine and then 4 theta. Now I start with a zoom 6 just to get it out there, and there's your graph. So you see it went really, really quick. And we want to see, just like other parametric equations, how is this graphing as our angle moves along. So to do that, we go back to our window, and you'll see we have all of this stuff. We can move our x in a little bit to get a better picture, like -5 to 5, and our y to -5 to 5. And then right here is our step. So if you want to slow it down, you make it much slower. So if we put a step of 0.01 and hit graph, you'll see now it moves a lot slower. So as our angle moves through theta, you could see it's creating this shape. And if we plug that function in here, you can see that it will go through and do one full graph into pi. So if I hit play, you can see it's creating the inside the exact same way. So that's our graph. So now we just need to know, where does it start and where does it end? So you can see with our graph that it's going to go from 0 to 2 pi. That was all the way around, makes one complete graph. So we're going to go from 0 to 2 pi. It's the main thing that we need here. And then now we just plug it in. And our integral is going to add up all of those sectors. So as we take our integral from 0 to 2 pi, it's going to calculate all those areas of all of those sectors and sum them up. It's going to add them all up, giving us our complete area. Forgot the square. And so we do this the same as we did before. We're just going to multiply it all out and see what we get. So we have 4 plus 4 sine 4 theta plus sine squared 4 theta. We distribute that half, so we end up with 2 plus 2 sine of 4 theta plus 1/2 sine squared 4 theta. I'm going to bring the d theta down in the integral at the very end. And so now we have 2 plus 2 sine 4 theta plus, and now this is going to be 1/4, so we got to use our double angle, 1 minus cosine of 8 theta. So again, we double that, and we double the denominator. So we get 2 and 2. All right, so now we have 2 plus 2 sine 4 theta. And remember, at the very end, you get to check with the calculator. So we're just going through the motions. If we make a mistake, we'll go back, fix it, and everything will work out. It's nice. All right, so now we end up with 5/4. Wait, 8 would be 9/4 plus 2 sine 4 theta, because I'm doing 2, which is 8/4, plus 1/4 is 9/4, minus 1/4 cosine 8 theta. It's very easy to make little simple errors on these. All right, now we can go 0 to 2 pi, because again, that's the full shape. All right, 9/4 theta plus, and then now here we end up with cosine of 4 theta, so we're going to have to take that 4, so it's 2 over 4. And since we end with a cosine, it's negative. And you can quickly check this. Derivative cosine of 4 theta would be negative sine 4 theta. The 4's cancel, take us back. All right. And then same thing here. This is going to be 1/4 times 1/8, and then sine of 8 theta. And you can check that one as well. 2 pi and 0. So now all I have to do is plug it in. So we have 9/4 times 2 pi minus 1/2 cosine of, I'm going to just put 8 pi just because we can, minus 1 over 64. 32 sine of 16 pi. And then now we change all the signs. So minus 9/4 times 0 plus 1/2 cosine of 0 minus 132 sine 0. All right. So we end up with 9/2 pi. And then 8 pi would be 1 and 0, so we don't have to put it. And then down here we end up with 0 and then 1/2. So adding these up, we end up with 9/2 pi, and that should be our answer. So now if we check it in our calculator, we hit math 9, 0 to 2 pi, and then 1/2, parenthesis, and now we're going to enter in our 2 plus sine 4 theta, 2 plus sine 4 theta. And you notice it's putting in theta now because our calculator is in polar form. So I have my 2 plus sine 4 theta squared d theta. I hit enter. And now if I check that, 9 times pi divided by 2, it gives me the exact same answer. So we're good. So again, our polar area of our polar region is just adding up the sectors. So if we have one of those sectors, right, just one, we use it as a reference to give us all of them from start to finish. There you go.